Hi, welcome to my video on the chain rule, more examples, number 1. And in this video, I'm going to do the derivative on composite functions, but I'm going to do a shortcut, recognizing that each of these are made up of composite functions, so we rather go through all the work that I did in the previous videos explaining it. Now I'm going to take a shortcut. Here we go, y prime. Y prime is dy dx, so the derivative of y in terms of x is y prime. So this is a composite, so we have the derivative of the whole function times the derivative of the inside, 2x cubed plus 4x. So this is the shortcut, recognizing that you have composite functions. And again, just to explain, the f of x is x to the 6th. The g of x is 2x cubed plus 4x. So this is the f of the g of x, so the g of x is going in here to get this function. So we do the derivative of this whole function here. So the x is changed to 2x cubed plus 4x, and we do the derivative of the g, which is right here. So y prime is, that's derivative of power rule, 6 goes in front, 2x cubed plus 4x, and decrease the 6 by 1, become a 5, and the derivative here, 2 times 3 is 6x squared plus 4. Number 2, again we're doing a derivative, and we recognize that this is a x to the 6th minus 3x plus 1, and the cube root is a 1/3. So again, it's the power. So y prime is the derivative of this whole function, and because you're doing the derivative of this power, so we just write that down to the 1/3. So we're doing the derivative of this whole function, but really we're doing the derivative of the 1/3 power times the derivative of the inside, which is the g of x. And that gives us 1/3 is in front, so 1/3 times 1. And so x to the 6th minus 3x plus 1. 1/3 minus 1 is negative 2/3. And the derivative of 6 to the x is 6x to the 5. Derivative of 3x is 3. Derivative of 1 is 0. And we continue to simplify that. We have 1/3 of, notice that 1/3, 3 is common here. So we can go 1/3 times 6 is 2, so it's 2x to the 5. 1/3 times 3 is negative 1. And this negative exponent goes to the bottom, so it's x to the 6th minus 3x plus 1 to the 2/3. And that becomes 2x to the 5 minus 1. If you want to write as a radical, it's the cube root of x to the 6th minus 3x plus 1 squared. And you can continue on to rationalize that if you want, multiplying top and bottom by the cube root of x to the 6th minus 3x plus 1, top and bottom, and the bottom just comes out to be x cubed, x to the 6th minus 3x plus 1. Okay, let's continue with number 3. Again, we got composite functions, so we have this is the inside, g of x, so it's y prime is the derivative of the whole function, like this, and the derivative of the inside, 4x squared minus 2. And the derivative is 1 over, derivative of ln is 1 over, so it's 1 over 4x squared minus 2. And the derivative of 4x squared is 8x. The derivative of 2 is 0. So that gives us just go sideways here, 8x all over 4x squared minus 2, 8x, and I notice that 2 is a common factor in the denominator, so 2 outside of 2x squared minus 1. So that becomes 4x over 2x squared minus 1. The common factor cancels out. Number 4, again we have, this is also written as the sine of x cubed. So the 3 here is the same as the sine of x cubed, understood. So y prime, again, the power, so we have the derivative of the whole derivative of sine x being cubed, the derivative, and the derivative of the inside is sine x, the derivative, so that's the g of x, so the power. So we're doing the derivative of the power of 3, so that's 3 sine x. Again, we do it squared. Derivative of sine x is cos x. And if you want, you can say 3, and you can go sine squared, is put the square there, so you can go sine of x all squared, which is understood to be the sine squared of x, times cos x. Again, more examples, and notice we're using the chain rule because we have composite functions. Okay, another one. The more I can show you, hopefully the more you understand. So this we have is 2x, and the square root is 1/2 power. So the derivative, again, is a composite function, because if you think about it, we have the f of x is 2 to the x, and the g of x is x to the half. So that x to the half is going right here to make this composite function. So it's the derivative of this function, so it's 2x to the 1/2 derivative times the derivative of the inside, which is 2x to the 1/2. And when we do the derivative of a number raised to an exponential here, we have derivative is 2x to the half ln of the base, which is 2, and times derivative here is that's 2 to the, oh, I got a 2 here. That's not 2. It's supposed to be x to the half, because that's the exponent. Okay, my mistake. That 2 is, so this is supposed to be x to the half derivative, because this is the exponent. So that becomes a half x. A half minus 1 is a negative a half. And we simplify that. We have 2x to the 1/2 times ln 2, and this is 1 over 2x to the 1/2. Okay, we keep simplifying here. Let's see, simplify that. So that's 2x to the 1/2 is the square root of x times ln 2, and that's 1 over 2x to the 1/2 is root square root of x. So we could simplify that to 2 root 2 to the root x ln 2 all over 2 root x. And again, we can multiply top and bottom by root x and rationalize if you wish. Sorry for that little error there, because this is the inside and this is the x to the half is the g of x, so that you got to do the root of the not the root, you got to do the derivative of x to the half. I have another one. So again, we have an example. We have, again, f of x is e to the x. The g of x is 3x squared. So the derivative of y prime is the derivative of what we see, the function is there, and the derivative of the g of x, which is 3x squared. And so y prime and the derivative of this function, derivative of e is e to the 3x squared. And, oh, I forgot to put the derivative right there. You gotta be careful. That's a 6x. And I'm going to simplify that, put the 6x in front, times e to the 3x squared. Again, you're doing the derivative of this main, again, because it's a composite function, you're the derivative of this function. But you're doing the derivative in terms of the e here, because it's not like, if you go back to this one, it's not like the 6th power. This is the power of this inside. Whereas, oops, sorry, right here, this is a power, but it's, again, the e of x. So you're doing the derivative of the e of x. And this is the g of x going in. Okay, let's do another one. Again, we have this could be a half tan x squared again. So the derivative. Now we have a half here, so that's a constant. So let's put the constant outside of here altogether. A constant goes outside. So because we have, we're doing the constants, so we take the constant and put it outside, we're doing the derivative of tan. So we're doing the tan of x being squared. We're doing the derivative of that times the inside, which is the tan of x. So that's the g of x, what's on the inside. So y prime becomes, there's the half, and so we do the derivative power rule, so it's a 2 tan x, so the 2 goes in front because of the power, and this is a 1, times derivative of tan x is secant squared x. So y prime, half times 2 is 1, so we get tan x secant squared x. Now we could have that, but if we want, just to explain, we could simplify this because tan is sine over cosine, and secant is 1 over cos squared. So that y prime could become sine x all over cos cubed, that's a 3 there, cos cubed x. So you could have 10x times secant squared x, or you could have sine x all over cos cubed x. Again, just to remind you, sine x, and this is understood to be the power. So cos cubed of the x is the same as cos of x cubed. Okay, we have another one to do, but notice now I took this one, and instead of the half being outside as a constant, I moved the half inside with the tan of this angle. So that means that this is the g of x, so y prime equals, it's the tan of a half x squared, and we're going to do the derivative of that times a half x squared. So you can see, again, just to keep, I gotta keep reminding, f of x is tan x, the g of x is half x squared. So there's the derivative of the tan of x. So you don't get fooled by this, because you're just doing the derivative of this. So the derivative of tan of x is And there it is there. You look at this. So it's the derivative of this is secant squared half x squared. So that's tan x, but now we have a half x squared, so it's the secant squared of this angle. And half, and that's x squared, the derivative of x squared is 2x. So it gives me y prime. And when we simplify, that's an x, because the 2's cancel out. Secant squared half x squared. So it's the derivative of this function and the derivative of the polynomial there. Hopefully it's, again, trying to make sense. The more examples you see done, the more it'll hopefully make sense. I'm going to do the derivative of each of these. And again, we have ln root x, so that's the ln of x to the 1/2. So again, f of x is ln x, the g of x is, make it the equal sign, x to the 1/2. So y prime is ln x to the 1/2. We're doing the derivative of this plus the derivative of the inside, which is x to the 1/2. And that becomes, derivative of ln is 1 over, whatever you have, 1 over x to the half. If that was ln x, it'd be 1 over x. If that was ln of x squared, it'd be 1 over x squared. So this is 1 over x to the 1/2 times, this is, so it's a half, power in front decreased by 1. So that's a half minus 1 is a negative a half. So let's keep simplifying. Y prime, so it's 1 over x to the 1/2. And this goes down, so that's 1 over the 2. 1/2 is 1 over 2. X to the negative a half becomes x to the half on the bottom. And that becomes 1 times 1 is 1. 2 times 1 is 2. And x to the half times x to the half is x to the 1. Because when you multiply these two, you either go x to the half times x to the half, is when you multiply like bases, you add the exponents, so that becomes a 1. Or you have square root of x times square root of x, because that's what a half is. Square root of x times the square root of x is the square root of x squared, and the square root of x squared is x. So either way, you get 1 over 2x. And again, now I did the root of, so I got ln x here and ln x, but notice the difference. So I have, this is the ln of x being squared, so this is a power. So y prime is the derivative of this function, which is ln x to the 1/2, so there's the derivative. And the inside is ln x to the derivative. And that works out to be the derivative of, this is as a power of ln, so 1/2 is in front. And this is ln x, 1/2 minus 1 is a negative a half. And the derivative of ln x is 1 over x. And we keep simplifying that. So we have 1/2 is a 1. There's the 2. And x to the negative a half, or sorry, ln x to the negative a half is 1 over ln x to the half times 1 over x. So that's y prime. So we have 1 times 1 is 1. We have 2x ln x to the 1/2. Y prime is 1, 2x root ln x. Again, if you want to multiply, and I'll just show you this, you can go further if you want. If you want to do root of ln x, root of ln x on top and bottom. So if you wanted to, that would be the root of ln x in the numerator, and your denominator would be 2x, and this would be the root of ln x, and the root of ln x is ln x. So if you want to go on further in here, just rationalize, then you could have this or this as your proper answer. Again, more examples explaining the derivative of composite functions using the chain rule. Hopefully trying to make things plainer, and they can be confusing. So the more examples you see, hopefully the more you'll understand. Click on the button. If you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.